Welcome back to the YouTube channel. I'm Xavier Smith, and today I'm going to teach you how to solve an equation that has more than two variables. I'm solving one that has three variables just because I don't have too much space on a whiteboard for one with more, but just know that I'm using the same method you would use to solve one with 4, 5, 6, and so on variables. So let me know if you need a video on solving an equation with 4 or 5 variables, and it's the same process. It's just if you had 4 variables, you'd have a fourth equation here and a fourth variable. So let's get started. First, we want to eliminate variables from two equations. So we'll have two equations where we have an eliminated variable, and then we have to solve that system of equations, which might seem a little complicated, but you'll see how it goes. And then at the end, we have to substitute that isolated variable back into one of these original equations. So if you need help with elimination or substitution, feel free to go watch the videos I've already posted on those. So our equations are x minus 3y plus 3z equals negative 4, 2x plus 3y minus z equals 15, 4x minus 3y minus z equals 19. Well, I see automatically we have a 3y in each of these equations, so we could cancel any of them, right? So I'm going to cancel these bottom two equations because they have a 3y and a z in common, which is going to make it, well, they're opposite sides, so it's not even going to work too well to our advantage. 2x plus 3y minus z equals 15. And then 4x minus 3y minus z equals 19. So we're going to get rid of these z's. We could get rid of the 3y or the z, but I'm going to choose the z's. So this is a negative z and a negative z. Well, if we added these, it would be a minus 2z, which that's not getting rid of. So we have to subtract these equations from each other. So let's subtract. 2x minus 4x is negative 2x. 3y minus negative 3y is positive 6y. Negative z minus negative z is 0. And 15 minus 19 is negative 4. Now, we need another equation that does not have a z in it. So then we can solve that series of equations through elimination. So let's find out how to get rid of a z again. Well, I see this 3z up here. We have to use it. And one of these other equations, I'm just going to pick this middle equation just because. And I'm going to get rid of the z. So x minus 3y plus 3z equals negative 4. Now, I have to find out how to get this equation to have the same coefficient. It doesn't have to be the same sign, just same coefficient as x minus 3y plus 3z equals negative 4. So I have to multiply this whole equation by 3 to get the same coefficient. So 2x times 3 is 6x. 3y times 3 is 9y. Minus z times 3 is minus 3z. And 15 times 3 is 45. Now, I have 3z and minus 3z. I'm going to add these equations because 3z minus positive 3z is 0. So that would cancel. So x minus 6x is negative 5x. Negative 3y plus 9y is 6y. Oh, I'm sorry. This is x plus 6x would be 7x. Negative 3y plus 9y is 6y. And 3z minus 3z is 0. Negative 4 plus 45 is 41. Now, I have two equations that both don't have a z in it. Now I just solve for one of these other variables. I see I have a 6y in both of them, so I can quickly cancel. I'll move this 7x down here, plus 6y equals 41. And I'm going to subtract these equations, so 6y minus 6y would be 0. So negative 2 minus 7x would be negative 9x. 6y minus 6y is 0. Negative 4 minus 41 is negative 45. Then we divide both sides by negative 9. Negative 9. Now, we have to think back to our multiplication. Negative 45 divided by negative 9. Well, negative 9 times negative 5 is negative 45. So, x equals 5. It's just negative 45 divided by negative 9. These negatives cancel, and it's 45 divided by 9, which is 5. So, x equals 5. Now what? Well, let's get rid of some of this work. I don't want to get rid of all of it, because I'm actually going to just plug back into one of these equations. All right? So let's choose this equation to plug back into. We can get rid of all this other work. I don't need it right now. We just have x equals 5, and then we have the simplified equation that doesn't have a z in it. Now what? Well, we can just substitute our 5 in. 7 times 5 plus 6y equals 41. So 35 plus 6y equals 41. Move the 35 over. 6y equals 6. Y equals 1. Isn't that simple? Make sure when you're plugging this x in, you're going to plug it into an equation that already has a variable canceled from it and has an x in it. Or else you're going to be going back and eliminating again, and that's just more work. So now that we have an x and a y, we have to plug it into an equation that also has the third variable. If you have 4 variables, you're going to plug this x into one that only has 2 variables. Again, you're going to have to simplify many equations. But you'll see how it works. Then you'll get this y, then you'll plug it into another equation that has 3 variables, then you'll plug it into this last one. But let's just start. Let's pick this middle equation of 2x plus 3y minus z equals 15. So that means 10 plus 3 minus z equals 15. So 13 minus z equals 15. That means minus z equals 2. So z equals negative 2. Well, we just solved, and we would put this as 5, 1, negative 2. Well, thank you for watching. Again, remember to eliminate, and you're going to eliminate one variable from 2 equations. Then you are going to solve that system of equations, and you're going to keep doing that as many variables as you have until you isolate a single variable. Then you're going to slowly keep plugging it back into equations until you solve for every variable. Now, thank you very much for watching. That was the whole buildup of our elimination, substitution, solving one variable, solving 2 variables. Now this is solving an equation with 2 or more variables. Thank you very much for watching, and I hope to see you again soon.